All right, let's do this. Today is 1/5. You ready for this? 26. That's the first time I've written the year in the new year. Yeah, so this entire thing that we're about to do is next up a unit that we do in this class. It just deals with, we just call the unit quadratics. But I break it up into pieces. The first part of it is we're going to do the mathy side of it, where we just solve equations different ways, like 4 or 5 different ways to solve quadratics. And it's not arbitrary, like it depends on the type of quadratic. So that's the first part of it, like I said, is the math. And then the second part of it is once we're good at solving them, then we start looking at their graphs. Um, so yeah, let's get to it. I think for this one, I'm going to keep it nice and easy. I'm calling an audible here. On my note card, I had something a little different, but I'm feeling like we should. Not much that we do today should feel like anything that you haven't done before. I taught all of you except 2 of you Algebra 1. So I know for a fact back in Algebra 1 that we did a unit on this back at the end of the year where we solved equations. So today we are solving specifically in one way only. So we are solving quadratics today. And they are quadratic equations by factoring. By the time I'm done with you here, by the end of middle of next week, we will have done factoring, completing the square, of course, the quadratic formula, and then using square roots. So those are going to be the 4 methods that we eventually learn. And again, it's not just you don't just pull one out of a hat. Like you start to get good at looking at a quadratic and understanding which method is the most appropriate, like which one's going to get me the least stress, which one's going to get me there quicker. But today it's all factoring. Okay. So given a quadratic equation like this, it's been a bit, I think, since you've done this. Anyone have any thoughts? Absolutely not. When we get to completing the square, adding 12 will be the right answer for the record. Getting that constant term out of there will eventually be the thing to do. But for today, we're solving by factoring. The idea behind this entire lesson, everything we do today is predicated on this idea that if you have 2 things, and we'll call them A and B. If I have an A and a B, they could be anything, M and N, a happy face, and a little drawing of a cat. It doesn't matter. If you have 2 things that multiply together that equal 0, then either A has to equal 0 or B has to equal 0, right? That's common sense. If 2 things multiply to make 0, one of them has to be 0. Maybe they're both 0, but at least one of them has to be 0, right? So the idea is to take this thing that I'm underlining and make it look like that thing that I just underlined. And that we do with factoring. And that's what we started this school year with in Algebra 2 was just a whole, like, I think it was like 6 weeks or something. All we did was factor, factor, factor. So you would recognize that it is already set equal to 0. And we're going to take the quadratic on the left and we're going to factor it down. And since it's just a basic bare bones quadratic expression, we're going to break it down into the shells. So forget for a moment that we're talking about equations and let's just go back to what we know from the past. And that is that to factor a quadratic, it's I need 2 numbers that multiply to make this and add to make this, right? These are the trial and error problems. So what do I know go in the fronts of these shells? Definitely an x and an x because x times x makes x squared. What are my signs going to be? One of each for sure because they multiply to make, I'll put a little yellow arrow pointing at it. If the 2 things are going to multiply to make a negative 12, then there has to be one of each, right? So we know we're dealing with a plus and a minus. And again, you'll remember that the order in which those go isn't important. What's important is that when we're done, everything adds out and checks out the way it's supposed to, right? And what numbers are we looking for here? Definitely some version of 2 and 6, right? So where do I want them? Like who? 6 at the back for sure, because I want that to weigh heavier. And I'll just draw this. I haven't drawn this in months in this class, but remember this times this plus this times this. You'll remember these. You've seen these dozens maybe of times. When I do the purple products and I add them together, they have to make negative 4x, which they do, right? 2x in the middle, negative 6x on the outside. And so that would be great if this problem were just this, right? If there was no equal sign and a zero, then hey, you did it. You factored the expression. But there is an equal sign and there is a zero. And so we have to rely now on this statement over here. And that is that if these two things multiply to make zero, then one or both of them has to equal zero. So let me underline them for you. I'll color code this. The green one, what would make it equal zero? There's one of your solutions, right? So negative 2 is a solution to this particular equation. If you put negative 2 back in, you'll get 0. And then the other one, I'll underline it in yellow, is this one. What makes him equal 0? And those are your two solutions, right? So that at its very basic, bare bones, is how you solve a quadratic equation by factoring. Everything I give you today, I've got 5 more examples after this, I think 6 more. Every one of them has factorability. Like I'm not going to give you anything today and say solve it by factoring and then, surprise suckers, you can't factor it. If that does happen, it's because I'm rusty and I wrote a bad problem. But the intent today is that everything will be factorable and that's how we're going to solve. Factor, solve, factor, solve. Okay. All right. So I'm going to change things up a little bit here. What's the first thing that catches your eye? What's different about this one than the last one? Sure. What else? Yep. What else? And maybe you know this, and I'm asking such an obvious question that you just don't want to answer it, but it's really important that you note that this is not set equal to 0. Again, this entire lesson today is founded on the idea that I will set things equal to 0. And if I don't have a 0 on that one side of the equal sign, then I'm not going anywhere. So job one is to pick a side and move all your stuff to one side. And it makes more sense to me in this case to pick up this term and move it over, and then to pick up the 8 and move it over. And the reason I say that is because when I add x squared to both sides, I will get a positive amount of x squareds. Everything that you do should be determined by how can I keep x squared from going negative. I don't want him to be a negative, the leading guy. Everyone else, they can be whatever they want, but everything we do is based on that. So how many x squareds will I have on the left? 3x squareds. How many x's will I have? The same thing is what's there. I mean, he doesn't have any partners. The minus 2x is just going to fly solo here. So like he's okay, but we got to put him in the right order, standard form, x squared, then x, then number. And what will my constant term be? Negative 8. Very good. So job one is set it equal to 0 and make sure that your x squared has a positive number in front of it. And then this is just going to be another build your shells problem. Slightly more difficult than its predecessor because we've got a number in front of x squared, but we're not scared chickens. So here we go. Please make sure you put the equals 0 at every step along the way. Well, not every step, at that step, because that's what, again, this is all based on, is that without the 0, then we're making stuff up. All right, let's do it. What do we know go in the front? 3x and 1x. Good job. And what are my signs going to be? One of each again. And the reason is because they multiply to make a negative something. And the plus and minus is why we have to use pencils. You guys that love pens, not a good time to use a pen. You want to be able to erase these because we might have our signs backwards. So we want to change those, right? All right, so we start thinking about numbers that multiply to make 8. And our options are 1, 8, 8, 1, 2, 4, 4, 2. And those are not the same, right? Where you put things matters because it'll interact with the numbers a different way. Anyone spot it?
2 and 4.
Uh, you want the 2 and the 4? Sure. How do we know if we factor well? I'm really glad we do this in this class again because I know part of this is Christmas break, but your answers are not coming as quickly as I would like. I know that this answer sucks because if I multiply those purple things, I get 2x, and if I multiply those purple things, I get minus 12, and 2 minus 12 is not minus 2. Remember that. So yay, we made -8, but obviously that's not the right solution. So let's not throw 2 and 4 out yet. Let's maybe try them in a different order. And if this doesn't work, then we can try some 1-8-8-1 combination. But let's try the 4 and the 2 swapped locations. What do the 2 in the middle make? 4x. What do the 2 on the outside make? -6. And 4 minus 6 is -2. So we did it. The factoring is done. And now we have to find the solutions. Factoring is just a means to an end. It always has been. Factoring in and of itself is a pointless endeavor, but when you apply it to solving an equation, it is not pointless. It's a very important tool to have in your toolbox. What makes this yellow thing equal 0? Pretend the 3's not here. Ready? Watch my magic pen. Ready? 3's gone. What would x be? -4. So the answer is -4 divided by 3. You have to divide by what's in front. And then the other one I think is pretty obvious. The green one is just x equals 2. Still good? All right, we got one more of this type. Any questions about that? All right. Thoughts? Why would you move the 6? It's not about how much work. Because I don't want the 12x squared to go negative. I will protect that at all costs. So I'm not going to move the 6 because it's less work. I'm going to move the 6 because this plus sign in front of the x squared is what I want. And if I move him to the left, because some of you are like, I like it on the left always. Don't be like that. Okay, bless you. If he's positive, you leave him alone. And if you want to swap it later, you can. But we want to take the 6 and move it across. And again, it's not about it being less work or more work. So I'm left with 0 on this side equals, and what order will I write this right side in? 12x squared leads the way. Minus x minus 6. And if you don't like that, that's okay. You can always go like this. Because some people have some pretty strong feelings about, I always want my problems to look the same. XC stuff on the left and 0 on the right. So at the end, where the 0 is becomes irrelevant. Good. Why does this problem suck? I don't know what you said. No, there's just a 1 on there. It's no big deal. There's 3 different potential shells. Thank you there, Parker. And so this, I wrote this problem with double intent. Number 1 was to have that conversation about you keep x squared positive. That was hurdle number 1. Hurdle number 2 is, we don't know if it's 12x and 1x, 6x and 2x, or 4x and 3x. What we do know is that the signs are 1 of each. Is this ringing some bells? It should be kind of having a flashback from September here. The good news is we're looking for numbers that multiply to make six. And so there's really only four possible ways to do this. It's either a one and a six, or a six and a one, or a three and a two, or a two and a three. So we as a team are going to dive in now. If there's 17 of us, 18 of us working together, we should be able to divide this task up and conquer. What do you want to try? Okay, and which numbers? Okay, and where do you want me to put them? In that order? Like a three here and a two here? Okay, let's give it a shot. By the way, remember, don't lose sight of this yellow thing up here. Our target is -1. I agree. And I'm not just going to jump there yet because we're all still a little bit rusty, but you nailed it almost. But this is the good kind of almost because all we got to do is a simple switch. Let's verify that this is close, but no cigar. If you multiply in the middle, what do you get? 9. On the outside, what do you get? 9 minus 8 is 1, but we wanted -1. And you'll remember that when we nail it, but the sign is off, we just switch our signs. We don't move anybody, we just switch the signs. So the plus and the minus get swapped out to become a minus and a plus. And then that changes the dynamic. Now you get -9 and +8, which add correctly to make -1. So good work there. That was pretty quick. So the solutions are going to come from the factors. This thing that I'm underlining is called a factor. It's a noun. What makes it equal 0? 3/4. Nice. And how about this one, the green one? -2/3. So that is flavor number 1. It's just a good old-fashioned 3-term build your shells trial and error quadratic. You good there? All right, flavor number 2, you'll recognize, I think, right away. Oh, what happened? Does not look like the others. What is this thing called? Anyone remember from months ago? Who said that? Good on you there, bud. It's a difference of squares. Good memory. It's a difference of squares. And when we factor a difference of squares, it factors super easy and quick into square root plus square root minus square root. Yeah, we love difference of squares. There's no trial and error. It's just robotic, easy peasy. What then are my solutions? Correct. From yellow comes -2, and from green comes +2. It is encouraged when you get answers like this that you write them not like this, but as m equals positive or -2. Okay. Good old-fashioned difference of two squares. What do we do? There's three answers to the question of what should I do first. Answer 1 is subtract the 9w squared. That answer sucks. Answer 2 is add the 12. That answer sucks today, but it won't someday. And then answer 3, the gold one for today, is subtract 37. And why do I want to subtract 37? So I can get my 0, right? Remember, today's lesson is entirety is predicated on let's make it equal 0. If it doesn't equal 0, that's your job. And I want to keep the 9w squared where he is because he's positive. So we are going to take the 37 and we're going to move it to the other side. And remember, in math, when you move it, you're doing the opposite. So you wind up with 9w squareds and -49. And what I ask you is this. That's a difference of squares, right? So we know it's just square root there, square root there. One gets a plus, one gets a minus. What then are my solutions? Nice. So those are two flavors now of solving quadratics by factoring. Number one is the good old school three-term build your shells trial and error. Flavor number two is the difference of two squares, which we love. We should, because they're easy, no thought involved. And then flavor number three are the ones that generally cause the most stress, and they'll be unique, but in a different way than what we just talked about. So for this, I'll start you out with one that's all prepped and ready to go. It's all equal to zero. How nice is that? This is not a standard three-term build your shells trial and error quadratic, and it is not a difference of squares, but it is unique because it's missing something. It's missing its third term, right? There's a void right here where you're used to there being a number like -12 or +24 or something like that, and it's not there. Um, these are the ones that cause the most problems. And they're the easiest ones, oddly enough, but they cause the most problems. So thoughts? You are going to pull out a G, C, F. And quadratics like this, you'll notice that it's missing the term that doesn't have an X, which means it's possible for both of these terms that I'm underlining to be factored down by an X, at least one X. I could take an X out. And if I do that, if I pull the X out to the front, then what's left? What's left of X squared if I chop out an X? Just X. And what's left of 11X if I chop out his X? Just 11. And you now have two things that are called factors. There is a red factor and a white factor. What could you put in place of X to make the red factor equal 0? What? I just can't hear you because of the heat. What did you say? Okay. The red factor. How could I change X into a number that would make the red thing equal 0? Thank you. So one of your solutions is 0. Now, there's also a white factor. That's this one. What would make him equal 0? Yes. Quadratics that look like this with a common X that you can pull out will always have one of their answers be 0. It's good to know. Our last example in our notes, and then we're going to work. A good quadratic equation solver knows how to focus on like prioritization. What am I thinking of first? Job one is maybe set it equal to 0. Job two is recognize your opponent. And then job three is dig through your toolbox to find the correct tool. You handy tool guys understand that. Once you know what job you're about to do, then you're going to go dig in and find the right tool for the job. And that's what solving quadratics is about, is find the right tool for the job. So priority one is let's make this equal 0. Do we want to move the 4p squared or move the 18p? Why? Because you want 4p squared to stay like he is, right? Don't mess him up. So we're going to pull the 18p to the right, and he'll become a minus. And the 0 technically is over there, right? But again, you're welcome to swap it at this point, free of charge. And since it's this kind, what do I do? The same thing I just did, which is what? Take out a Gary Charles Franklin, right? And what can you get out of both of these terms? You can get a 2. And You cannot get a 4. 18 cannot be divided by 4. It is not, well, I mean, you could, but it's going to be ugly. What? No. What else can you get out? A P. I didn't ask for an AOCF, any old common factor. No, I want the G, greatest. I want to pull as much as I can. So if I pull out a 2 and a P, that's my red guy. What's left when I'm done? What's left of 4P squared if I pull out a 2 and a P? What's he left as? Just 2P. Because he used to be P squared, but we took one of his P's. So he got knocked down, brought down a notch. And what's left of the 18P if I divide him by 2 and yank out the variable? Just a 9. And in front of you, you now have 2 items. This one that I'm circling in yellow is called, I want to keep stressing this to you, that thing as a noun is called a factor. This green thing as a noun is called a factor. We use the word 2 different ways. To factor as a verb is an action, but what you create are nouns, things called factors. And your job is to make the factors equal 0. What makes the yellow-red one equal 0? It's the most common wrong answer is people every time, every year, hundreds of times of delivering this lesson, and people will always say -2. But try it for yourself. If you put -2 right where that red arrow is pointing, 2 times -2 is -4. That does not work. Just 0 is what we want. And I said this before, and you can take this to the bank. Anytime you're doing a problem like this and you pull a GCF that has a variable, it can be x, 2p, 3x squared. If it's a little single chunk with a variable, one of your answers will always be 0. And what makes the green oval thing equal 0? No! 9/2. Right. Well done. Good. That is how you solve quadratic equations by factoring. You will either see the 3-termers where you build your shells and trial and error it until it works, or you'll see the 2-termers that are differences of squares that you'll factor robotically, or you'll see the 2-termers that both have the variables that you GCF out and solve like we just did. And now, as you would expect, I have a worksheet that's full of those 3 types of problems, right? Good to go? D. Floy, you feel good? Rad.